So for this one, if we go ahead and subtract 5 on both sides, we get x is greater than or equal to 5. Or, if we subtract 6 on both sides of this one, x is greater than negative 17. So again, this is not about the solving, it's about the graph at the end. And the graph at the end for this one's a little bit weird. If we set up our number line, we've got 0, negative 5, positive 5, negative 17. The 5 is a solid dot. The 17 is an empty circle. But again, we're going to graph the arrows completely separate as if the other one wasn't even there. So for the 5, should it go to the left or to the right? Okay, so from the 5, I have an arrow that goes to the right. On the 17, the negative 17, should the arrow go left or right? That one should also go right. Now this time they both went in the same direction. But again, because it's all in the same graph, what we end up with is really an overlap where this arrow that started at negative 17, it includes everything over here. We don't need this dot at the 5. This arrow already covers all of it. This swallows it and keeps going. It's the same thing the whole way through, which means that the actual graph for this should just be the one arrow. So there's the 5, there's the negative 17. This one arrow covers all of it. There's no weird response for this, like all real numbers. It's just that. That one graph is it. Unfortunately, what this means, the frustrating part, is that if you go through and you get to a problem like this, it means that this inequality was completely useless. It told you absolutely nothing and was not worth doing. This inequality is the only thing that you really needed, because this one inequality covers all the solutions to both of them.